Okay, so in this lecture, we are going to study about generating the points on an arc of hyperbola. So we will start the method first. So what is an analytic equation? Analytical equation of a hyperbola. We know that a hyperbola is given by x square upon a square minus y square upon b square is equal to 1. Okay, and what are the parametric equations? The parametric equations are x is equal x comma y is given by what? A cos hyperbolic theta comma b sine hyperbolic theta, where what is the value of theta? The value of theta varies from 0 to pi by 2. Okay, so this is the way we are going to get the hyperbola. So I will just draw in brief. It will look like this. The hyperbola looks like this. These are the points A and minus A. Okay, so we are going to generate now points on this hyperbola. We are going to concentrate on only the first quadrants for these problems. So we are going to generate points like this. This will be our target. Okay, and so on. So before that, do we know what are the hyperbolic functions? So what is cos hyperbolic theta and what is sine hyperbolic theta? So we know that sine hyperbolic theta is equal to e power theta minus e power minus theta divided by 2. And what is cos hyperbolic theta? Cos hyperbolic theta is e power theta plus e power minus theta divided by 2. Okay, both these functions are increasing functions. We are going to need this property of these functions later on. So both these functions are increasing functions. Okay, now say the next thing that we should know is about what is sine hyperbolic theta plus phi. What is sine hyperbolic theta plus phi? It is equal to same as sine and cos. Sine a plus b के जैसा ही है. So it is sine hyperbolic theta cos hyperbolic phi plus cos hyperbolic theta sine hyperbolic phi. Okay, so and what about cos hyperbolic? So let me write it here also. Cos hyperbolic theta plus phi is also equal to cos hyperbolic theta cos hyperbolic phi plus sine hyperbolic theta sine hyperbolic phi. We're going to need this. Okay, now let us go to the iterative technique with this background. So iterative technique. What we will do is we will take the hyperbolic arc, showing you the diagram. We'll take the hyperbolic arc from some value of x. Okay, the actual hyperbola goes like this. Okay, so I will take the hyperbolic arc from some value of x. Let me say this value is x min and this value is x max. So we are going to concentrate only on this part of this arc of hyperbola. Okay, so this is x min and this is x max. So we are going to only concentrate on this part. Let me make it change its color. So we are going to look at only this arc. Okay, and we are going to generate points on this arc. The hyperbola goes ahead. So we are going to take the first point over here. Say I'm going to call it P1. The next point I'm going to take say P2 and so on. In general, I'm going to call the ith point as Pi, and the next point I'm going to call Pi plus 1. Okay, and then we are going to join the origin with Pi. I'm also going to join the origin with Pi plus 1. Okay, now there is a difference of angle, so the angle width of Pi I'm going to denote by theta I. The angle that OPI plus 1 makes with respect to x-axis, I'm going to call it theta I plus 1. And this small angle that we have got here, this small angle, I'm going to call this difference of angles, I'm going to call delta theta. Okay, so what is delta theta? Delta theta is the angle between OPI and OPI plus 1. Okay, so let x lie between two values, x min and x max. Okay, and let delta theta be angle between OPI and OPI plus 1, line segment OPI and OPI plus 1. And what is theta I? Theta I is the angle made by OPI with respect to x-axis, and theta I plus 1 is the angle made with Pi plus 1, OPI plus 1 with respect to x-axis. So what is delta theta equal to? Obviously delta theta is equal to theta I plus 1 minus theta I. Okay, theta I and theta I plus 1 I have shown you in the figure. So this eventually means that theta I plus 1 will be equal to theta I plus delta theta I. Now the point Pi plus 1, which I'm going to denote by xi plus 1, yi plus 1, will be equal to a cos hyperbolic theta I plus 1, b sin hyperbolic theta I plus 1. But what is theta I plus 1? Theta I plus 1 is equal to, this is delta theta, sorry. It's equal to a cos hyperbolic theta I plus delta theta, comma, b sin hyperbolic theta I plus delta theta. Now we have seen the formulas above. What is cos of theta I plus delta theta? So it is equal to a cos hyperbolic theta I cos hyperbolic delta theta I plus e, I'm multiplying the e again, sin hyperbolic theta I sin hyperbolic delta theta, comma, second coordinate will be b sin hyperbolic theta I cos hyperbolic delta theta plus sin hyperbolic b sin hyperbolic theta I, sorry, it's cos hyperbolic theta I sin hyperbolic delta theta. Okay, now what is this equal to? A cos hyperbolic theta I is actually xi cos hyperbolic delta theta, or delta theta I, plus A sin hyperbolic delta theta I is yi sin hyperbolic delta theta, comma, this is sorry, this is not yi, this is not yi. I have to make some change here because it is b sin hyperbolic, right? So I will have to adjust a b here. So let me multiply a b and let me write a upon b here. So this sin hyperbolic theta I will now become yi. Okay, you have to be careful. And here what I have is b sin hyperbolic theta I is yi cos hyperbolic delta theta, plus here again I need a, so I will have a cos hyperbolic theta I. This will become b upon a into sin hyperbolic delta theta. Okay, why I did this? Because I know that this person will become yi and this person will become xi. So we will get xi cos hyperbolic delta theta plus a upon b. This is yi sin hyperbolic delta theta, comma, what will this become? Next, the second coordinate will become yi cos hyperbolic delta theta plus b upon a xi, this person will become xi sin hyperbolic delta theta. Can we write this in the form of a matrix again? Yes, we can represent this in the form of a matrix, which is equal to xi plus 1 yi plus 1 is equal to xi yi multiplied by a 2 by 2 matrix. What is a 2 by 2 matrix? The 2 by 2 matrix is xi cos hyperbolic delta theta yi multiplied by a upon b sin hyperbolic theta. So it will be a upon b sin hyperbolic theta. Then here I will have, with respect to xi, I am multiplying b upon a sin hyperbolic delta theta, and with respect to with yi I am going to multiply cos hyperbolic delta theta. So we have got the formula. Recurrence formula is that the next point pi plus 1 will be nothing but pi multiplied by this particular matrix cos hyperbolic delta theta, b upon a sin hyperbolic delta theta, and a upon b sin hyperbolic delta theta, and cos hyperbolic delta theta. So this matrix is going to be very useful for us. For that we need to know what is delta theta. What is delta theta? Obviously delta theta will be what? So if I'm having a hyperbolic arc which is like this, and this is the, let me draw it like this. So this is the minimum angle which I'm going to call theta min. Theta min corresponds to x minimum, and the maximum angle that I'm going to have here is, that is corresponding to x max, the maximum value of x, and that angle I'm going to denote as what? I'm going to denote as theta max. And how many points we're supposed to generate? We're supposed to generate here n points. So in this case, we know if the arc is open, you have to divide the total angle by n minus 1. So delta theta here will be how much? Will be theta max minus theta min divided by what? Divided by n minus 1 to generate how many points? To generate n points. Why am I taking n minus 1? I hope that is clear, because the arc is a open arc, it's not a closed arc. So we understand that this will be our recurrence formula to generate the points. This will be the value of delta theta that we are going to need here. Okay, and for that we need to find what is theta max and theta min. Now how will I find theta max and theta min? Okay, so let me say case 1. If the value of x is given, if the x is restricted from x min to x max, then the value of delta theta will be different. And for other case, for values of y, the value of delta theta will be different, right? Now we all know that x is equal to what? X is equal to a cos hyperbolic theta. So what is value of x min? X min must be a cos hyperbolic theta minimum. What is value of x max? Therefore, a cos hyperbolic theta maximum. Therefore, from these two, we will get the value of x theta min and theta max, right? How will you get the value of theta min? The value of theta min will be, you will take x min divided by a, and you will get cos hyperbolic theta min, and therefore what will be your value of theta min? Therefore value of theta min will be cos hyperbolic inverse of x min upon a. Similarly, when I look at the second equation, theta max will become how much? Theta max will become cos hyperbolic inverse x max upon a. Okay, so these are the values of theta min and theta max, and therefore I will get the value of delta theta, which I am supposed to put in the matrix. What is the value of delta theta? Theta max upon theta min divided by n minus 1. This was the first case when the values of x are given to us. Okay, the arc has x min and x max is given to us. For in the second case, what will be the possibility? Suppose you are given y min is less than or equal to y is less than or equal to y max. Okay, then we all know what is y given by. Y is equal to what? Y is equal to b sine hyperbolic theta. In that case, y min will become how much? Y min will become b sine hyperbolic theta min, and y max will become b sine hyperbolic theta max. Okay, and therefore accordingly, what will be the value of theta min? And from this you will get theta min is equal to y min upon b, and its sine hyperbolic inverse of this, and theta max is going to be sine hyperbolic inverse of y max upon b. Okay, and once I get values of theta min and theta max, my value of delta theta will be the same. It will be theta max minus theta min upon n minus 1. Okay, so now with this background, we can now solve some problems. So let me move to the first question. So I'm going to generate 5 uniformly spaced points on a hyperbolic segment in first quadrant, where the values of x were for they restricting the value of x from 6 to 12. So the hyperbola is x square upon 9 minus y square upon 4 is equal to 1. Okay, solution. So here a square is 9, b square is 4, so a is 3 and b is 2. Okay, what is x min and x max given to us in the problem? We know that x min and x max is given to be 6 less than x less than 12. So x min is 6 and x max is 12. As soon as I get x min and x max, I will find theta min. Theta min will be equal to cos hyperbolic inverse x min upon a, okay, which is equal to cos hyperbolic inverse 6 upon 3, which is cos hyperbolic inverse 2. Okay, we'll use my calculator and find the value of cos hyperbolic inverse 2, and that comes up to be 1.3169. Okay, how does this come to be 1.3169? Let's just give me a minute. I will first type 2, okay, and then I will type cos hyperbolic, so it will give me 1.316. so that is what I have written, cos hyperbolic of 2. Now what is theta max? Theta max is cos hyperbolic inverse of x max upon a, which is cos hyperbolic inverse of 12 upon 3, because x max is 12 and a is 3, so it is cos hyperbolic inverse of 4. And when I go to my calculator and I type 4 and its cos hyperbolic inverse, I'm getting 2.0634. so I'm going to write that 2.0634. and when I go for delta theta will be theta max minus theta min divided by n minus 1. We have to generate 5 points, so n is 5, right? So it will be 2.0634 minus 1.3169 divided by 4, and that comes out to be 0.1866. Now we will use a recursive formula. The recursive formula is xi plus 1 yi plus 1 is equal to xi yi multiplied by the matrix cos hyperbolic delta theta, so b upon a sin hyperbolic delta theta, then a upon b sin hyperbolic delta theta, and cos hyperbolic delta theta, right? We have the values now with us, xi yi comma yi, then cos hyperbolic delta theta is 0.1866. b upon a means it is 2 upon 3 sin hyperbolic 0.1866, then 3 upon 2 sin hyperbolic 0.1866, and cos hyperbolic 0.1866. okay, and this calculation comes up to be, I'm writing the numbers now, 1.0174, 0.1251, this is 0.2815, and this is again 1.0174. okay, so this will be our matrix A, and this is the formula which will generate our points xi plus 1 yi plus 1. okay, so the only questions comes and falls down first point that I should start with. So the first point that I should start with, my curve starts here, so I will start with this point itself, where this is x min is given to us and x max is also given to us, right? So this is the first and the last point. So this point I have to start with. What is the angle for this point? The angle for this point is theta minimum, right? Correct. So what is this point given by? So the first point is x1, y1, okay, which is given by what? Which is given by a cos hyperbolic theta min, comma, b sine hyperbolic theta min. Do we know what is theta min equal to? We have calculated theta min above. Theta min was how much? 1.3169. So the point P1 will turn out to be A. A is 3 cos hyperbolic theta min. Theta min was how much? It was 1.3169, comma, B is how much? 2. So it is 2 sine hyperbolic theta min. Theta min was again 1.3169. Sorry. Okay. And now I will go in my calculator and calculate this first point P1. And this first point P1 comes out to be 5.996 comma 3.463. This comes up to be your first point, and then you know how to generate the second point. Second point will be p1 star a and so on, and you will generate the 5 points till p5 is equal to p4 star a. We will generate all these points using Scilab now. Okay, and then we will go into GeoGebra and plot those points. Okay, and we will really observe that the hyperbolic arc must lie between what? It must lie between 6 to 12. For x is 6 to 12. This is the hyperbolic arc it should come, and the points must be, you must be able to generate 5 points. Okay, now there, when I show you this in GeoGebra, you will observe that these points here need not look equidistant. They need not be equidistant. They are uniformly spaced according to the angles. So these angles will be equal. So delta theta is going to remain constant for all of them. Okay. So let us go to Scilab now. It is 1.0174, comma, this next row entry 0.1251. The second row is 0.2815 and 1.0174. So this is the matrix A. The point P1 that we have decided is 5.9996 and 3.4630. And the second point P2 is P1 star A. Third point P3 is P2 star A. The fourth point is P4 P3 star A. Fifth point is P4 star A. So these are the 5 points. So let me put them in a single matrix: P1, P2, P3, P4, and P5. So these are the 5 points that will be generated using GeoGebra now. So we enter the points now. The first point was 5.9996, comma 3.4630. The first point. The second point is 7.07882. 4.2738. The second point of the hyperbola. Third point is 8.4050, comma 5.2337. Third point. The fourth point is 10.0246, comma 6.3762. The fifth point, the final point, is 11.9939, comma 7.7413. So these are the points of that hyperbola. What was the original hyperbola? The hyperbola is x square upon 9 minus y square upon 4 is equal to 1. So you see the points are exactly generated on this hyperbolic arc, and observe the value of x lies between 6 to 12. See, the value of x is lying between 6 to 12. Let me just draw the segment so it will be clear extremely. So the line is from 6 to 12 is the line segment. Okay, we have drawn these 5 points on the hyperbola. Now we will move to the second question of generating points in a hyperbola. So we will generate 4 uniformly spaced points on a hyperbola in the first quadrant, where now I'm going to take the range or the limits for y 3 less than or equal to y less than or equal to 6, where the hyperbola is given by x square upon 9 minus y square upon 25 is equal to 1. Okay, so how am I going to do this problem now? So here first of all, a square is 9 and b square is 25, so a is 3 and b is 5. The value of y min and y max is given to us, so this is 3 less than or equal to y less than or equal to 6. So y min is 3 and y max is how much? It is 6. Okay, once you know that if you're given y min and y max, then your theta min and theta max will be depending on sine hyperbolic inverse. So theta min will be sine hyperbolic inverse of y min upon b, and which is equal to sine hyperbolic inverse of y min is 3 upon 5. Here in my calculator is 3 upon 5, and to find its sine hyperbolic inverse, its sine hyperbolic inverse comes out to be 0.5688. So I'm going to enter that. 0.5688. And what about theta max? Theta max is sine hyperbolic inverse of y max upon b, and that is equal to sine hyperbolic inverse of 6 upon 5. Okay, and that is coming up to be 6 upon 5, and its sine hyperbolic inverse is 1.0159, which is 1.0159, and therefore my value of delta theta is theta max minus theta min upon n minus 1. How many points we are supposed to generate? We are supposed to generate 4 points, so it is equal to 1.0159 minus 0.5688 divided by 3, and that comes up to be delta theta is 0.1490. What is the initial point that I'm going to consider? The initial point I'm going to consider is x min y min, correct? And so initial point P1. Okay, let me write the matrix A first. What is matrix A? Matrix A, the rotation matrix will be cos hyperbolic delta theta, B upon A sine hyperbolic delta theta, then A upon B sine hyperbolic delta theta, and cos hyperbolic delta theta. I'm going to evaluate all these values, and I'm going to get pi plus 1 is equal to pi into the matrix A, that is xi plus 1 is yi plus 1 is equal to xi yi, and here I'm going to put the values of delta theta A and B. Accordingly, I'm going to get 1.0111, 0.2492, then 0.0897 and 1.0111. What is the first point that I should consider? The first point that I should consider is x-min and y-min always, right? What is the values of y are given to us, right? So what is x-min equal to? X-min is nothing but a cos hyperbolic theta min, right? And y-min is given to us. Y is given in which range? Y is given in the range of what? Y is 3 to 6. So y-min is 3. So this will be directly 3. So this is equal to 3 cos hyperbolic theta min. Theta min we have calculated above. It comes out to be 0.5688. And here I have 3. When I put this in calculator and get the value, multiply it by 3, that comes out to be 3.4985, 3. So this will be the first point of the hyperbola. Accordingly, I will generate the second point as P1 star A and so on till I get the fourth point P4 is P3 star A. Now we will go into Scilab and find out these points and then plot them in GeoGebra. So the matrix that A we have got is 1.0111, 0.2492 and 0.0897 and 1.0111. So this is the matrix A. The first point that we have chosen is 3.4985 and 3. So accordingly we will get P2 is equal to P1 star A. So we'll give the second point is this. The third point will be P3 is P2 star A and fourth point is P4 is which is P3 star A. So these are the 4 points that we have generated. Let me write them together. So it is P1, P2, P3 and P4. These are the 4 points that we are going to draw on in GeoGebra now. First point was 3.4985, 3. The second point was 3.8064, 3.9051. The third point is 4.1989, 4.897. The fourth point was 4.6847, 5.997. So these are the 4 points. You can see them. They are accordingly on the sheet aside. And what was the equation of the hyperbola? The equation of hyperbola was x square upon 9 minus y square upon 25 is equal to 1. So this is a hyperbola. Let's zoom it. So what are the restrictions? What were the restrictions of y? The restrictions of y were that y coordinate should lie between 3 to 6. So see here I'm showing it. It's exactly all the points are lying within this given range. Y coordinate lies between 3 to 6. So these are the 4 points generated on the hyperbola.